The use of explosives in the mining industry has always been a potentially hazardous business.
Hey, Dave, let's go ahead and drill that next hole out.
Well, you better check it. Check that boat light. Be sure that hole's clear.
Nah, forget it. Go ahead and drill it out.
The first priority of the mining industry must always be the health and safety of the miners. Every effort should be made to avoid blasting accidents.
Charlie, what happened? Well, best we can understand, Keith was standing right here shoveling out for his snake hole. David had just got through drilling that hole there, and he moved up to this one here. And when Keith evidently raised up, it flowed him over, and his head was laying right there, and his feet were laying up here. You know, Charlie, miners have been told time and time again not to drill in big legs. Well, there's one guy that won't drill in anymore.
The fact is, blasting materials today are safer and more controllable than ever before. Why should needless accidents continue to occur?
Gentlemen, we're gathering here in an attempt to gather the facts.
In examining blasting accidents, the answer seems clear. The vast majority are caused by violations of one or more explosive safety regulations.
Here are some drawings that were sketched at the scene of the accident.
Although records show that violations and accidents occur in transportation and storage, it is in the use of explosives that most fatalities and injuries occur. Underground mining in metal and non-metal operations covers a wide variety of ore and geological conditions, shot sizes and drilling angles. For this reason, blast plans are established and should be followed as closely as possible. While each operation is responsible for establishing its own specific procedures, there are some basic safety procedures that should always be followed when blasting. These procedures fall into 4 categories: drilling, loading, detonation, and post-blast examination. Let's look at each step to see how accidents can be prevented. Before drilling actually begins, loose material should be barred down. Regulations state that the area must be inspected for hazards. One of the hazards could be undetonated explosives. The area should be thoroughly examined for evidence of misfires. If undetonated explosives or detonators are discovered, they should be reported to the proper supervisor and should be disposed of before other work is performed in the area. In addition to visual observations, blasting galvanometers should be used to test for continuity and resistance on any electric blasting cap wires that are found. Only when you are convinced that the area is free from misfires and other hazards should drilling begin. Drilling pattern calculations can be quite complex. They include various elements that will assure a good blast with minimum hazard. The number, depth, spacing, and angle of the boreholes must be considered, as well as the amount and type of explosives and detonators. As each hole is completed, it should be checked for obstructions before moving on to the next. Often, the only inspection tool a driller has is the drill itself. With experience, the driller develops a feel for the drill steel as he removes it. When all holes appear to be properly drilled and in good shape, the next step may begin. The choice of explosives and detonators, like the blast plan, is a decision based on a number of variables. Technology is providing safer, more controllable blasting products, but these new products, like older ones, must be handled properly to ensure safety. When transporting explosives, only the amount required for a particular blast should be brought to the site. If electric blasting caps are used, all electrically operated equipment within 50 feet of boreholes containing electric blasting caps should be de-energized.
Okay, let's go back.
Stray current tests should be conducted. The maximum tolerable stray current is 0.05 amps through a 1 ohm resistor. Loading should begin as close as possible to blasting time. A tamping pole made of non-sparking material is used to test for obstructions. The hole punch, too, should be made of non-sparking material. The primer should always be prepared immediately prior to loading it into the drill hole. The electric blasting cap should be inserted deep within the cartridge to help in preventing it from being accidentally pulled out. For further protection, the cap lead should be firmly tied around the cartridge. To minimize the possibility of misfires, the primer cartridge should be loaded with the cap pointing toward the collar. The primer should never be tamped directly, but should have one or more cartridges between it and the tamping pole to act as a cushion. Usually, 2 or 3 light blows are sufficient to produce good compaction. Sometimes a steady push is all that's needed. With experience, the loader will develop the feel for proper tamping. Once charging operations have been completed, all unused explosives and detonators should be removed to a safe location. Special precautions should be taken in mines employing pneumatic loading. Powder being blown through the hose can cause a buildup of an electrostatic charge, which can cause initiation of both electrical and non-electrical detonators. It is essential, therefore, to dissipate this buildup of static electricity. The hose must be semiconductive, and proper grounding of equipment is extremely important. Lightning can detonate electric blasting caps below the ground as well as above, for distances up to several miles. If an electrical storm is detected while blasting, electrical charging shall be suspended in shaft sinking, tunneling, and other operations.
Telephone call for Larry. Hello, Larry.
Yeah, Harry.
An electrical storm will hit here in about 10 minutes. Get your blasters out of the face area.
Bad lightning storm will be here in about 10 minutes. I'll tell them.
All personnel shall be withdrawn to a safe location within the mine.
One more. Hey, fellas, I just got a call from upstairs that there's a bad storm coming, so we better shut this stuff up if you're ready to get out of here for a while. Good enough. Thank you, right, fellas.
The use of electric blasting caps requires that resistance and continuity tests must be made. Accident data show that a variety of instruments have been used to conduct these tests. Some have had the sufficient current to set off the charge. Only approved blasting galvanometers or instruments designed for testing electric blasting caps should be used to test blasting circuits and components. Of course, blasting lines must be kept shunted, except when being tested, until immediately before blasting. Loading and testing according to approved procedures is the best way to assure a proper blast and the elimination of misfires and their hazards.
Oh, sir, Charlie? Yeah, I reckon they got it all wired anymore.
We have reached the most critical step in the entire blasting process, detonation. Explosives should always be handled by experienced miners or others under their direct supervision. It is especially important in this stage that only authorized individuals be involved.
Okay, what do you say we do this in about 5 minutes, right? Boy, you go up there and walk that corner, Charlie and I'll go down here and get ready and set her off, okay?
Having one person in charge eliminates communication problems that can cause confusion and accidents. Regulations require that the blast area be barricaded, posted, flagged, or guarded against unauthorized entry. Pre-arranged timetables and signals must be completely understood. This is especially important in underground mining, where visibility is limited. All persons must be cleared and removed from areas endangered by the blast, and it is the guard's responsibility to allow no one to enter the blast area.
Setting off a blast up here, you have to hold up a minute.
Consideration must be given to toxic fumes as well as the concussion and fly rock when establishing safe distances. Once the prearranged blasting time has been reached, ample warning must be given.
Fire the hole! Fire the hole! Fire the hole!
Immediately after a blast, smoke, dust, and toxic fumes fill the site, creating a hazardous condition. Under no circumstances should anyone be allowed to re-enter the area until it is cleared. After the smoke and fumes have cleared and the roof has been inspected, faces and muck piles should be thoroughly examined for undetonated explosives. Look for powder, wires, or other evidence of misfires. Electric blasting cap leg wires should be tested with a blasting galvanometer. Evidence of misfire should be reported to the proper supervisor, and any undetonated explosives disposed of before other work is performed in the area. It must be understood that blasting is an art.
Okay, hold it.
An art that takes years of experience to master. It is not uncommon to encounter unusual situations that are not covered by established procedures.
Oh, we got a blocked hole here, Bill.
If it should happen to you, don't let your actions exceed your knowledge. When lives are at stake, you can't afford to count on guesses. If you have a question,
What are we going to do about that, Clark?
ask for help.
We could load it on out. Well, we could.
The federal regulations written by the Mine Safety and Health Administration are not suggestions.
That's a good idea.
They're the law. Their sole purpose is to protect you. The steps outlined follow federal explosive safety regulations and apply to all underground mine blasting. But each mine operation has its own unique conditions, which may necessitate additional safety rules. These, as well as the federal regulations, are designed for your benefit, to keep you and your fellow miners from being involved in accidents. Remember, detonators should be securely embedded and properly directed within the cartridge. Proper placement of the primer in the bore hole and careful handling of the blasting leads will also reduce the number of misfires. It is especially important to remember that injuries and deaths can be greatly reduced by properly clearing, posting, and guarding all blast sites and by using clearly defined communications.
Fire in the hole! Fire in the hole! Fire in the hole!
And ample warning signals. If every miner complied with these regulations, the great majority of blasting-related accidents could be avoided.